All right. So this is my talk on observables. And it covers two things, observables and why you should care. Why it is important, what are these things we keep hearing about. Why they are actually useful in our day-to-day life. And so in this talk, we're going to go through examples, and I'm going to try to avoid an hour of just pure hypothetical things and never actually looking at code. So let's dig through a lot of code here. Hopefully it doesn't go by too fast, and everybody will be able to figure out what's going on. First and foremost, this is me. My name is Randall Koutnik. I am a UI engineer at Netflix. And Netflix absolutely loves RX and all of the streaming technology because we're a streaming company. Surprise, surprise, and we do a lot of work with both RxJS and RxJava. So what's this Rx thing I keep talking about? So an observable, well, I mean, this is a talk on what are observables, so we'll cover what observables are. Rx in particular, when I talk about it, is this implementation of observables. Rx stands for reactive extensions. You can find them in all sorts of languages. So if you're not a JavaScripter, that's OK. We'll have some examples in JavaScript, but the concepts we cover will go to .NET, C#, Java, all sorts of Java, JVM derivatives. These things are everywhere. So in order to cover what an observable is, let's cover some ground to make sure everyone's on the same page. This is a variable. It contains a single value. Stop me if I'm going too fast. Not only does it contain a single value, but it contains that value at the moment we declare it. When we want it to hold the value, it does. This is an array. It contains a collection of values. Again, at the moment we want it to. We say, you contain these values, and it does. We can add and subtract and manipulate it, and all happens instantly. Now, unfortunately for us in programming, we can't just do everything instantly. That would be fantastic, and I understand that all of our bosses think we can do everything instantly, but it doesn't work that way. So we have to deal with asynchronous stuff. We need to go ask another microservice or a database, give me this data. We need to make a call to a backend. We need to work in ways where the data we want may not be immediately available. And one way of handling that is to simply block the entire thread until the data becomes available, which is a little silly. Now, I like to think about imagine if my wife said, you know, I'm out. When I come back, can you help me unload the groceries? And I said, yes, I can help unload the groceries. And I just sat absolutely still on the couch and did nothing at all until my wife came back with the groceries. Now, I would be ready at the moment she came back to unload the groceries, but I am really bad at sitting still. And I'd like to get some other things done in the meantime. So we need some sort of way to say, when the groceries come back, let's do something. And we do. They're called promises. And in this case, we make a query to a database, and then the variable myPromise contains a single value, the data returned from the database, but it doesn't contain it instantly. It says, at some point in the future, I will get this data. And we unwrap that by adding .then. Say, all right, when the data comes back, do whatever we want to do with the data. In the meantime, move on down the code and handle other things. So far I've talked about 3 different concepts, and none of them are observables. But by process of elimination, I'm sure you all can figure out where observables fits in. And so an observable is a collection of data where the data it contains arrives at some point in the future. So in this case, we have clicks on a button. I'm in the UI space right now, so I think a lot about buttons. And all of the clicks on a particular button is a collection of data, but it's not all going to arrive at one point. That would be horrific if every click ever issued on a button arrived at a single point in time. But at some point in the future, the user will click on the buttons. And since this is an asynchronous abstraction, we need to unwrap that value. In this case, through subscribe. I want to listen in to the clicks on the button. So then we get to the key point. And if you leave this talk with one thing, this should be it. An observable represents collection of values where those values are delivered at some point in the future. So there you go. That's what observables are. I'm done. You can go to lunch early, except for that really pesky subtitle in my talk. Why should I care? And of course, this is the talk before lunch, which is the worst slot ever because everyone's hungry and irritated. So I'll try and get through it because I know that everything, especially in the 2017, all of development, everyone seems to be throwing out new frameworks, new libraries, new techniques, new abstractions all the time. And I'm doing that too. I am contributing to that mess. And this is why I think you should pay attention to observables. I think you should pay attention to observables because we can build a stopwatch. Bear with me for a moment. Let's think about a stopwatch, because a stopwatch contains 3 sources of information delivered over time. We have 2 buttons, start and stop. Those clicks on those buttons will arrive over time. And we have a secret behind-the-scenes thing where the time will increment as the stopwatch is running. If you've never used a stopwatch before, you press start, keeps track of how many seconds have, sorry, I'm talking too fast. Keeps track of how many seconds have happened since you press start. And when you press stop, it stops. Nothing fancy there. So let's make an observable. Enough talk about what they are. Let's actually put one together. So line by line. First off, declare the variable 10th second $sign. And in observable land, often we add a $sign to the end of a variable as sort of a notation to say, this is an observable, you're going to call observable methods on it, et cetera, et cetera. If you don't like it, don't do it. I use it here for illustration purposes, and that's what the $sign is for. Next up, we have the standard usual constructor, new rx.observable, and we pass a function in that contains a single parameter, observer. So far, so good. Then we declare a variable that is 0, set that, we've got that. Then we have an interval, because we need to keep track of things. And our interval, every 1/10 of a second, will call observer.next with the current value of the counter, and then increment that counter. And finally, we return a function that clears that interval. So what's going on here? Why is this important? Why is this useful? So an observable, values over time, when we have that observer that we've passed in. And the observer, when we say observer.next, we say, I have a new value, whatever that value is. I can pass it in. And that lets everyone down the line, all of the subscribers, all of the methods and things we attach, know we have a new value. In this case, it's a number. That's it. That's simple. But it could be as complicated as a new chat message or a new database row to process or things like that. This is JavaScript. We don't do typing. And finally, we return a new function. And that function clears the interval. And this is where observables start becoming powerful. Because we have an interval, and it's going to continue ticking along until we tell it to stop. And this observable will not do anything until someone subscribes. And when someone subscribes, it will run all of this logic, create the interval, and start sending values. And when that person unsubscribes, says, I'm done. I don't care anymore about what you've got for me. The observable will run this final function. I think this is a laser. There we go. And clean up after itself. So what that means is the actual consumer of the observable does not need to worry about memory leaks or extra CPU cycles behind the scenes or all sorts of really fun things that result in people calling you at 3 in the morning saying, the app is broken. You don't need to worry about that anymore. So, of course, this sounds complicated. Even though this is only maybe 6 or 7 lines of code, that's a lot of new stuff to learn. So I'm sure the next question in everyone's mind is, how do I get Netflix to do all the work for me because I'm lazy? And fortunately, there's a way. In Rx, we have our own observable type called interval that does exactly what you just saw. There is no functional difference between these two snippets of code. This one's just simpler, and someone at Netflix gets the headache if there's a bug in it. So, all right. We've finally built an observable and found a bit of a roadblock. Because this observable, the values it delivers are the number of deciseconds, tenths of a second, since we started, since we subscribed. And so we don't want that. We want to display the number of seconds. So we need to take every value in our stream and divide it by 10. So to solve this problem, we need to dig into functional programming. And I promise, this is not scary. This is not going to talk about monads or monoids or mono-endo. I don't care. This is going to be simple stuff. I don't know all of that either. We're going to talk about map. And map is a simple concept that takes an array and a function. Or rather, it takes a collection and a function, to be specific, an array in this case, applies the function you give it to every item in the collection, and returns a new collection with the results of that function. So we have a function here. It multiplies a number by 2. Have a collection, 1, 2, 3. Result, 2, 4, 6. Not too complicated. So since map operates on a collection, observables are collections, all we have to do is say, all right, take 10 seconds, map, take every item, divide it by 10. Simple so far. Now, nothing is going to happen here. We can declare all of this code, and it won't do anything, because no one is listening in. Observables are lazy. They only do work when they know someone's going to listen to them. So we need to subscribe. Say, hey, I'm actually going to do something. And this is an incredibly common pattern if you're ever in the UI space, is to do all of your business logic in the observable, get the source value, manipulate it however you want, and then finally, in the subscribe call, put the value on the page. So here we're just setting it on inner text and just plop it there. We don't care too much about frameworks or doing things correctly, because this is an incredibly trivial example. So that's one. That's our behind-the-scenes counter taken care of. And now we've got the other two, the buttons. And again, things are simple. So we use query selector, grab the values off the page, and then we have from event as a way to create an observable. And from event takes an element and the name of an event and returns an observable that fires whenever the event happens. So far, so simple. We can put it all together into 12 lines of code. 6 of them are variable declarations. And the rest is our actual business logic that we need to worry about. So at the start, when all of this code runs, there will be no timer going in the background. There won't even be a listener for click events on the stop button, because we don't care. We will listen to click events on the start button, because we've subscribed. And for every click event on the start button, we then take our 10th of a second. That will initiate, map over it, divide every item by 10. And then we've got this new thing, because I've been tricky. I've given you homework. We have take until. Now, fortunately, we can think about this. Take until is attached to a root observable, and we pass in a second observable in. So we're going to take until takes values from the root observable it's attached to until the observable we pass in emits a value. So what this is saying is continue taking events from our timer until the user presses stop. All in one line. And not even a confusing line. And finally, we have our subscription, which is actually going to trigger. And the nice thing about take until is when the user clicks on the stop button, it's going to unsubscribe from both the timer and stop clicks, which means their deconstructors run. No more interval, no more click event. We only are running the things on the page that we're actually going to use. So let's see if I can get the demo running. We have 2 buttons. Click stop, nothing happens. No one is listening to stop. Click start, we start putting numbers on a page. then we can see as the number increments as I talk and talk and talk and talk and talk, until finally stop is pressed, and we finished. The page is no longer updated. There's no timer running. No one's listening to stop until I press start again, when the whole process starts over. Surprise, surprise. And we do want to stop that as I go on. So, how are we feeling? That was a lot of new stuff just to get a stopwatch running. I mean, come on, you could probably build that in your sleep with your preferred language and framework. But while we were building that stopwatch, while we were saying, all right, how do we time how long Randall is talking, did you notice we solved a lot of different problems too? We solved the problem of, upon an initiating event, do something until there's a concluding event, which means we've solved drag and drop. And if you're on the front end and you've tried to do drag and drop, you understand exactly what a frustrating headache it is to figure this out without observables. Listen for the mouse down. Keep updating the position on the page until there's a mouse up. We've also solved loading bars, which are a wonderful source of race conditions and headaches and torn out hair. But in this case, it's just when the load starts, listen to the asset pipeline, take until, for whatever reason, we stop loading. Maybe it finished. Maybe the user decided to cancel. Maybe there's an error. And for every item, just update the loading bar on the page. And we're all programmers, so we all know just how much we love chat rooms. When the user enters the room, subscribe to the room stream. Update the page with every item until the user leaves the room. Then everything will clean up after itself. Everything we do in programming can be modeled like this, can be modeled as a stream, even if that stream contains 0, 1, or infinity number of events, infinite events. So, okay, I made this sound really nice. I made it sound like we've now solved literally every problem in programming, and that's not true. Because we still have to deal with that problem I talked about in the beginning, when we want to deal with data that isn't there yet. So I work at Netflix. Has anyone here heard of Netflix? We're a tiny little startup over in Los Gatos. We have this nice little feature in the corner called search. And you can click on search, and you can start typing, and it will suggest answers until you finish typing out whatever movie you want to see, and we tell you that movie isn't available. And here's some other movies you didn't want to see that we do have. But in that technique of trying to figure out what the user wants before they have finished typing and displaying those results on the page, where you type ahead of what the user wants, is called, unsurprisingly, Typeahead. For once, naming is easy. But Typeahead itself, building that out, is really complicated because there's a lot of things going on. So this is a naive implementation. All right, listen for the key-up event. Whenever that happens, grab the value of the text box, send that off to the server, and when the server comes back with a result, put the suggestions on the page. Now, since we're running, on our corporate network that has 400 gajillion megabits per second, or however that works, we're never going to encounter latency or trouble or anything like that. So all of this is probably going to happen in order. And then we release it to production, and this happens. User types A, send the request off. User types AB, send the request off. Then the request for A comes back. We say, got it. Put the results on the page. Then the user types C, so now the full query is ABC. Send the request off. Then the request for ABC comes back. I don't know, maybe because it was a longer request, there were fewer records to search, so that query happened faster. Maybe it got routed through, one got routed through an overloaded router and the other didn't. We don't know. Networks are evil, and they're out to get you. So the ABC comes back. We dutifully say, hey, put it on the page. And then AB comes back. We dutifully put it on the page. And the user is looking at a page that is representing results that is not what they asked for, and they get very angry. And they go on Twitter, and they yell at you, and your boss gets mad, and lots of tickets are filed, and you get woken up at 3 in the morning because something went wrong. So if you've ever worked at a startup, you know how startups fix this. Just keep slapping on patches until people stop complaining. And we can add in, keeping track of state. We can put state into the request itself, so the server sends back, this is the request for AB, this is the request for AB. which means that the back-end programmers have to make a change, which means a whole deployment, and they get mad at you again. This is complicated. This being the talk on observables, you can probably guess what I think the better way is. So let's build that out with Rx. And again, we're lazy programmers, so we'll build a typeahead that searches Stack Overflow. So we'll start off the first line. We know what this is. We've seen this. This is from the stopwatch, from event. Got an input box, got to grab the key up event. Then we see map. We remember what map does. It takes every value and returns a new value from the function. In this case, we take the key up event and just grab the value of the text box. What's the string in there? We don't care about the rest of the event. And then we get to switch map. There's a switch map up there, and we're like, oh, I know what maps are, but I don't know what a switch map is, and this sounds complicated. So let's skip it. Let's forget about that. Keep moving on. In the results area, set the inner HTML to nothing and clear out that. OK, so we made a new request. Clear out the old request. We see Rx observable Ajax. We haven't heard of this before, but I bet we can make a really good guess as to what it does. Does it make an Ajax request? And the answer is yes. To the URL, we pass it, and it makes a request. And it comes back as observable, comes back with the result of the Ajax request. Fantastic. Moving on, we see MergeMap. And much like the switch map above, we know what map is. We don't know, we never heard of MergeMap. We haven't talked about merging before. Don't know about that. Let's skip it, move on. We'll get back to it later. And we see subscribe, and we're back in home territory. We know how subscribe works. We know the first function is going to be for every value, add that value to the results area. And then we see another function with the parameter This is our function. If there's an anywhere in the application, this function is triggered. It's an observable, an error, something goes wrong. The entire stream will just crash and die and send down the error for the error handler to say, all right, take this. In this case, just alert. Just tell the user, hey, something went wrong. I'm done. So about that switch in MergeMap. We're going to dip a second toe into functional programming for a second and talk about flatten. And flatten means take a collection that has collections of collections of collections of and unpack it. Now, sometimes flatten, as in this case, unpacks it as much as possible. But most of the time we talk about flatten, we're just talking about unpacking one layer. So we can unpack arrays, as in this example, but there are other things that are unpackable as well. Promises, for instance. Flattening a promise means to unpack it and only return the resulting data from the promise. And we can take our two functional programming concepts we've learned today and look at Flatmap. And what Flatmap does is it maps and then flattens the result, which is annoying because we call it Flatmap, but really it should be called map flat, but that's harder to say, I guess. So this mapping function is fairly arbitrary, but we do end up getting nested arrays, and then it will flatten that out. So from 1, 2, 3, 4 to array of 2, array of 4, array of 6, array of 8 to just 2, 4, 6, 8, because that one's really simple. So what on earth does this have to do with switch and MergeMap? MergeMap's the easier one. When you take multiple observables and put them all together, that's called merging. So instead of calling it Flatmap, we call it MergeMap, since we're merging rather than flattening. It's a semi-arbitrary choice, but that's what it's called in Rx land. So in this case, response.json has a property called questions. It's an array. MergeMap takes that array and unwraps it one layer, because we're still inside an observable, and just sends each individual question down as a single event, rather than one event containing a whole array. Which means that everyone down the line can say, I only have to think about, as a programmer, when I write these functions, a single question. I don't have to worry about iterating over arrays. I don't have to worry about promises or observables or anything like that. Just a single question, which makes our lives so much simpler. And then we get to the bigger one, switchMap. SwitchMap is a special kind of MergeMap. It's a tricksy function, because this one is returning an observable. So you remember the whole, type AB, type ABC, and all of a sudden ABC comes back. What MergeMap does is says, all right, we're going to fire off a request. We'll type fire off AB, and that request is in flight. We haven't heard back from it yet, but we got a new value. We got ABC. So it says, all right, I have a request in flight, and I have a new value. So I'm just going to throw away the old one and switch map to the new value and only pay attention to the new value. So when the new value goes to the server, comes back, that's what I'm going to pass on down the line and completely ignore the previous one. In fact, it's going to unsubscribe, which cancels the in-flight request, which behind the scenes may end up saving us a lot of CPU time. So that whole A, AB, ABC, back and forth, all handled. And not only that, we didn't have to handle it. Rx did. And there's another really important thing happening here. The code is executed in the order we read it. Because our puny meatbag minds like to read things from top to bottom. And really, really often, code does not execute from top to bottom because they're calling functions here and there, and because this actually is called, but it doesn't resolve until that does, and With Rx, our code executes in the order we write it. We don't need to worry about parts of the code until we get to them. So let's take a look at the demo. So you have our search box, and a nice little model here. We can see key ups, mapping to get the value, grabbing the search results, and then actually putting the question titles on the page. Put this on. There we go. And you can see that even though 4 requests were made, only 2 were paid attention to. Only 2 we actually cared about because we canceled 2 of those requests as things went on. And you can see, in a really terrible manner, because I didn't style this at all, but you can see that we did get some answers and put them on the page. How are we feeling? All right, all right? A little like all this mapping and flattening and merging, but we're starting to see why these can be so powerful and expressive when we write code. So we heard a little bit about Angular 2, and a couple people were interested in Angular 2. So, let's look at Angular 2. And Angular 2 uses Rx for all of its asynchronous stuff, including AJAX requests. Now, when they first announced this, I got all programmer mad and ragey and started pounding out angry internet comments on my really loud mechanical keyboard. And one of the developers mentioned and said, actually, check this out. And it was super awesome to reach out to me and post this code, and I read this code, and I just kind of moment of reached enlightenment. So let's walk through it bit by bit. In this, we are going to pretend to be a new ride-sharing service. Since Uber seems to be crashing and burning, there's probably an opening in the field. We want to tell the user the status of the car that is coming to pick them up. First thing we do, grab HTTP and import statement. We've seen import statements before. That's not exciting. We've also seen observable.interval. It's not exciting either. That's old news. But it's going to trigger once every 5 seconds. Then we'd say our responses are going to take ticks. We've seen switch map. Yes, we know what switch map is. It's going to take the value and then throw it away. We'll get a new value before the old value. Got it. And in that switch map is remarkably the same thing we saw before, except with Angular's HTTP instead of observable.ajax. Angular's HTTP being integrated into the Angular framework, and therefore it can talk to the framework. Grab the car status.json or whatever endpoint we want to hit. And then we've got retry. This is a really magical thing behind the scenes. Because when things go wrong, when errors happen, what do? You refresh the page. As I like to joke, you never put the UI engineers on pager duty, because when we have a memory leak, people just refresh the page, the servers don't go down. And then people remind me of all the memory leaks my pages have had, and I shut up in meetings. But in this, we have to look at retry. We have to understand a little bit more about how observables work. So retry, unsurprisingly, is going to retry whatever it's attached to. 3 times, in fact. And it's attached to an AJAX request. The AJAX request shoots out, and it fails. Maybe we're just on 3G, and it's just kind of coming in and out. Or maybe the servers are overloaded for a second. Whatever. Again, networks hate us. So if something fails, and we could put a nice error message for the user. Sorry, our entire service is down. Good luck. Or what we can do is unsubscribe, which means that all of that cleanup logic is run, and then resubscribe, which re-triggers an AJAX request. Send off another one. In fact, try 3 times before we finally give up. So if we're in an area with a shaky connection or something like that, all of a sudden, we're able to display the correct information to the user, even if it takes us a little longer, and do that refresh page behind the scenes. The user doesn't even notice, which is a fantastic experience. And so now we can start to see how an AJAX request, even though originally I'm like, this is a promise. It represents a single value delivered over time. Maybe it's not a single value. Maybe we want to retry and things like that. And then finally, we take map, and we know what map is. This is boring. Come on. And grab the JSON out of the request. Finally, whenever we do end up with a successful AJAX request, we update the map. This is, again, put the UI, the view logic, in the subscribe. And finally, we've done a lot. There's multiple AJAX requests being fired off. We've got a timer and all that. When the car arrives, a single unsubscribe says, I'm done. Everyone up the line, clean up after yourselves, and we're finished. Don't have all sorts of intervals and things spinning off, using up the user's bandwidth cap, burning the user's battery. They get a much better experience from our code. So, still a lot to go there. Let's talk about hot and cold observables. Because so far, I've been talking about cold. A cold observable is just like we've been talking about. Whenever you subscribe, it runs the constructor logic, tells you the stuff. You unsubscribe, it goes away. You can resubscribe, and then it all runs again. Fantastic. On the other hand, say we've got a web page, and there are 17 different components on the web page that say, I want some value about the currently logged in user. OK, that sounds reasonable. Well, I'll just have them make an observable AJAX request. And so we fire off 17 AJAX requests. And that's if everything works. If something breaks, we then fire off 17 times 2 or 3 or 4 per page load. And all of a sudden, one of the backend engineers comes running after us with pages and pages of server logs printed out and starts shouting about us how we've DDoSed ourselves. And we've made so many requests from a single user page that it brought down the whole backend. And again, we've got to fix it. So we need some way to share the results rather than resubscribing every time. Let's take a look at some pretty pictures, because everyone likes pretty pictures. So here we have how a cold observable looks. For every subscription, we create an entirely new chain, which means the cleanup logic can clean up item by item, which means that we can take advantage of shaky networks by just resubscribing, try the request again. On the other hand, there are times when we want this. We want one single chain, and the end result goes out to everybody. How do we get that? Let's talk about Wikipedia, because we are all colossal nerds. Wikipedia has a WebSocket stream that emits a value every time something changes somewhere on some Wikimedia page. The US version, the Wikimedia itself, all sorts of different, the meta, whatever. It'll send us a value. And this is fantastic for dealing with streaming data or stream data processing, which is where I kind of got my start in just kind of figuring out how things worked. Or if you want to work with visualizations as well. So we start off. Wikistream $$ means that it's observable. All right, great. Rx observable, pass in O. Got some setup logic whenever we have a new change, value, call O.next. We know what that does. When there's an error, we call O.error. We don't know what that does. Never heard of that before. But from the context, that we can figure it out, it calls the error function. And the error comes through there. And finally, when we're done, clean up. We know that. And now we have a problem, because if we have a lot of different bits that want to figure out what's going on in Wikipedia, and we don't know what hot observables are, we're going to have a whole bunch of subscriptions, a whole bunch of socket connections, and Wikipedia will actually ban you for 15 minutes if you open up too many connections from the same IP. Guess how I figured this out? And then I learned what hot observables were. And we have publish. And publish is what takes an observable and makes that split. So publish is making this split right here. And then once we've published, we have two options for how to deal with the original subscription. Connect here, we call connect next. We say, all right, immediately subscribe to the original function. And always, never unsubscribe. Just keep listening and passing on data, regardless if we have 0, 1, or 472 subscriptions. Which is nice. It's simple. It's one connection. It'll never break, or well, I don't want to say it'll never break, but it'll never unsubscribe. On the other hand, it might be a bit much. Maybe we only want to use this every minute out of 10 minutes or something like that. In that case, we have ref count. And ref count keeps a count of the references, or subscriptions, to the root observable. So long as there is someone listening, it will emit data, but as soon as the last listener unsubscribes, it will also unsubscribe from the root observable and pass that back and forth. So I typically use connect because, again, I am lazy and it just works, but there are occasions when I do need the cycles or whatever, and I use ref count. These are the two options. And you can see down at the bottom, we have not one, but two different subscriptions, pass it into a bunch of statistics libraries to calculate statistical things, as well as buffer time, which is a new one. But that one's simple too. Takes all the values for 100 milliseconds and passes them down as one big batch. So it buffers up for 100 milliseconds, then passes it down. Buffers up, passes it down, which allows us to handle the data in batch form. So we only update the graphs every 1/10 of a second. And all of this code and all of this explaining gives us something that looks like this. And we can see all of the Wikipedia edits as they happen. And the graphs, as you notice, are only updating once every 1/10 of a second instead of as everything goes along. So a quick summary here, because I understand hot and cold can be difficult as a more advanced concept, especially if you're just starting out. A hot will allow you to split a single connection. A cold will allow you to retry, if you will. So we got a few more minutes, a few more things to talk about. So let's look at that Typeahead example. Because, like any good programmer, it could be better. This is the first half. We added a few new things. We have our, again, the same thing, grab the input element, grab the value. But in this case, if there are fewer than 3 characters in the Typeahead, we probably can't guess what movie they're thinking of or what Stack Overflow question they want. If the query is A, simply saying, here's all the Stack Overflow questions that involve the letter A, will not actually help our user. So in this case, we'll say, let's hold off until there are at least this many characters. Secondly, we have debounce. How many people have heard of or used a debounce function? Yeah, a couple nods, a couple nods. I'll go over it for a second. How debounce works here is I handed a value, and debounce says, all right, I have the value. I am not doing anything with it. I'm going to wait 333 milliseconds before passing it on. And 332 milliseconds later, I handed a new value. It throws away the old value and says, all right, I have a new value. I'm going to wait 333 milliseconds. And then 333 milliseconds passes and says, all right, my timer is up. I'm going to pass that on. The practical upshot of which is if we hand it a ton of values all at once, it's going to wait until there's a pause in the input before finally sending the latest value it received on. So if you're a fast typist, we're not going to send a request for every keystroke. We're going to wait until you've finished typing before sending a request. And even then, we have one more function, and this is my favorite because it takes something that typically would be really complicated, and I've written it so many times before I discovered observables. We have distinct until changed. And distinct until changed, we hand it a value. It says, all right, this is the first value I've seen. I'll just pass it on. I have no history to record. Then we hand it another value. It looks at that value, compares it to the previous one, and says, this is different. These are 2 different values. So that new one, I'm going to pass it on and then store it. And we hand it a third value. And it says, this is identical. This is the same as the previous value. I'm not going to do anything with it because you haven't changed. It's a special type of filter that keeps an internal state and says only pass on when the new value has changed something. Because as many programmers, myself included, have discovered by sending off an inordinate amount of requests, pressing left and right, if you happen to be the sort of person who fidgets a lot, I don't know anyone like that, pressing left and right in an input box is a key up event, which means that if we sit there and press left and right 100 times, it's going to send 100 requests in the space of a second or two, which makes backend programmers angry again. Distinct until changed, one line, one function, all the headaches go away. And on the other side of things, we have our switch map. Works the same way. We haven't changed that much. We've added in a catch below it. So instead of just blasting an error, or retrying, as it were, because we don't want to retry in this case because it's not an AJAX request at its root. Excuse me, it's an input box. We can catch. If there is an error, simply pass this value on, and we have pass on empty set of questions. And keep going. Do not immediately fail. We don't want the user to suddenly, because something went wrong in the network, never be able to search. So we'll have some safety there. Same MergeMap we saw before. Same subscribe. Interesting thing now is now that we've added catch, unless somehow the MergeMap dies, we will never see this error trigger. We've added a third function to our subscribe. 3. Let's hope 3 isn't too many. And it is our done function. Because there are certain types of observables that finish. AJAX, for instance. An AJAX observable can say, when my request has finished or errored, or well, actually, when my request is finished, pass on the request result, and then say, I'm done. If anyone is listening in to what I have, tell them, I will emit no more variables, no more data. And this can be useful. There are other types of observables that are infinite. We have an infinite stream of data passing through them. They will never call done. An event observable, like the one we have here from the input, is such an infinite stream. So this function will never, ever be called. I only put it there because I wanted to show off. So these are the 3 types of functions you pass into subscribe: dealing with data, dealing with errors, and dealing with when the observable finishes. So let's have our third and final demo. Close that out and see our new improved Typeahead with lots and lots of fun things. So what's the first thing to do? Type in the letter O. Our filter nabs it. I don't have enough information to ask the server. Now it gets past the filter, the debounce waits, then it is a new value, send off the search, get the result. And then I can do my fidgeting and press left and right, and the debounce will catch it, and say, all right, I'll emit 1 value. 1 is still too many. Nothing's changed. Distinct prevents that from happening. So again, we're sending no requests off to the API, and we won't get banned, which is no fun. Until, of course, we actually change what's going on. So that is what I have for you today. These 4 people helped inordinately in me putting together this presentation. Ben Lesh, Jafar Hussain, Jay Phelps, and Rob Wormald are all fantastic people. You should find them on the internet and listen to what they have to say. And finally, I have stickers. They say Netflix. I hear people like Netflix stickers. Come and find me, because everyone knows how good of a developer you are is intrinsically related to how many stickers you have on your laptop. All right, thank you. Any questions, come on forward.